Okay, this is how I'm going to do this. I'm going to go through the questions that deal with us having to do some calculations. The questions that deal with always, sometimes never, or true or false, or vocabulary style questions. I'm going to skip over those and allow you to look through them, relearn that information if you need to, ask me questions if you need to in the next day or so about those questions. But this is just going to be for working with the calculations. Okay, so this first question says angle SMU is x plus 7. So we're talking this angle here is x plus 7. They're telling us that UMY, which is the entire angle, is negative 2x plus 89. I'll come back to that in a minute. But they tell us that SMY, which is this blue angle, is 13x plus 18. Okay, so if we look at this as the angle addition postulate, the red angle and the blue angle should add up to give me UMY, which is going to be this total angle right here, which was the negative 2x plus 89. Okay, so the two smaller angles, x plus 7 and 13x plus 18, should add together to give me negative 2x plus 89. That's going to give me 14x. When I add that one and that one, I'm going to get plus 25 is then equal to negative 2x plus 89. When I move the negative 2x over, I'll add 2x here, add 2x there. So we get 16x plus 25 is equal to 89. Subtract 25 from both sides, so 16x equals 64, and x has to be 4. Okay, so that'd be 4. Now it says find the angle of, or the measurement of angle UMS. Okay, well, UMS was right there, it's the red one. It's x plus 7, so it's going to be 11 degrees. SMY was 13, x plus 18. Well, now x is 4, so 13 times 4 is 42, plus 18 then should be 60. And now try UMY. Okay, if I go negative 2 times 4, which would be negative 8, add to that 89. Okay, so negative 8 plus 89 would be 81. Okay, I'm sorry. Right here, SMY, 13x times 4, that's 52. 52 plus 18, that's going to give me 70. So that's actually a 70. So now we check that 11 plus 70 gives me my 81. Okay. This is question 3. Ultimately pretty similar to the last one, except for it's kind of a unique situation of the angle addition postulate and the fact that it's the angle bisector. If I have an angle bisector, they're saying ray BT is an angle bisector. So it's going to tell us that that angle right there and that angle right there are congruent. That's what the definition of an angle bisector does. So we're going to have 1/2 x plus 24 is equal to 3x minus 46. If these two things are congruent, then their measurements are equal. Now, just to make things a little bit easier on ourselves, maybe we want to multiply everything by 2 to get rid of this 1/2. So I multiply everything by 2, I would get 1x plus 48 is equal to 6x minus then, let's say, going to be 92. I'm going to move my x over, so give me 5x here. Okay, I'll add 92 to both sides, so that should give me 140. I'll divide both sides by 5. Okay, so give me x here. That will go in there. 5 will go into 14 2 times. We'll be 40, so 28. So x should be 28. and then when I plug that back in to find ABC, okay, um, ultimately ABC, there's two ways we can approach this. We can actually just plug in X to either that one or to that one, doesn't matter which one we do, um, and then that's going to tell us the measurement of maybe that angle right there. Well, if that's an angle bisector, then that green angle and that red angle have to be the same. So when I plug X in here, 28 times a half will give me 14. Add to it 24. Okay, so there's 38. So this angle here is 38 degrees. If that's an angle bisector, then this has to be 38 degrees as well. So 38 plus 38 is 76. So measure of angle ABC is 76 degrees. Okay, question 4 says to find the area of a square with the perimeter of 32. We talked about squares. Perimeter formula for a square is 4 times S. That's S, that's S, that's S. Perimeter is the distance all the way around. So tell me 32 should equal 4S. Divide both sides by 4, you get 8 is equal to S. So that's 8, and that's 8. We talk about the area formula for a square being S squared. Well, S is 8, so we go S, or 8 squared gives me 64. There's my answer. Question 14 is asking us to deal with finding specific angles. Angle DAF is the first one we want to look at. So the first thing you want to do is kind of highlight the rays that DAF are, or angle DAF is being created by. So the first one's that one. Okay, so that's DAF. Now, when I look at this, if I'm going to use the rule, or sorry, the protractor postulate, I've got to make sure that I use the same row of values both times. So so that's 90 right there. So this ray is going through 90. This ray is going through 0. Okay, and we talked about finding that angle then between those two rays was the absolute value of one ray minus the other ray, or the coordinates of those rays. So it gives me 90 degrees. Therefore, angle DAF is 90 degrees. Let's try one that's a little bit more difficult. If we go EAS, okay, so EAS, E to A to S is going to be that angle there. Okay, so if I'm looking at this, I'm going to just go ahead and use these bottom numbers on this one. There's 70 for that ray, and it looks like this one's going through 25. Okay, so I can take the absolute value of 70 minus 25, and that's going to give me 55. Sorry, 45. That's going to be 45 degrees then for that angle right there. Okay, simply take the two coordinates and subtract them. I would have gotten the same thing if I would have gone if I used this number up here, 110. If I use 110 there, I've got to come over here and use 155. Well, 110 minus 155, absolute value, is still going to be 45 degrees. Okay. RAE. RAE, we're looking at that ray and that ray. So again, this ray AE is going through 70, and ray R is going through 140. Okay, using those bottom rows again. So that absolute value then is going to give me 70 degrees. And then you can do the same thing for, I'll leave you to do angle CAS. Basically, this is going to be 25. If I use the top row, 25. This one's going to be 155. Go ahead and subtract those, and you'll get your result. Okay. I'll talk about this one here. It says name the two planes that intersect in WV, line WV, and the figure below, or figure to the right. First thing you want to do is find the line that they're talking about. So if I look at WV, it's that line right there. Okay. Now, once you find that line, the best thing to do is then say, okay, what two planes intersect to create that? So if I look at this plane right here, and I look at that plane right there, those are the two planes that come together to create line WV. Okay, so when I name that blue one, and this is the way we talk about planes, there's four letters actually there to talk about that plane, that blue plane. I'm going to just list them as U, X, W, and V. The green plane has R, S, W, and V. Now, when we talk about naming planes, we only need three of these four letters. So we got to look down here and see if any of these options incorporate those three of those four letters, and then likewise three of these four letters, and that will be our answer then. So if I look at the first one, WXU, well, there's W, there's X, that's U. So they're talking about the blue plane, so that's okay. And now they go UXT. Well, UXT is not in this green plane, so it can't be option A. All right, again, UXW in part B, that's okay. That names the blue plane. And then SRV. Well, SRV are 3 points in that plane. Option B is our answer. Okay, now some of you might have go all the way down to option D eventually, but you're going to follow that pattern of saying, okay, how do which one of these answers has basically three of those four letters and three of those four letters? Okay. Okay, this one here, it's question 37. It's asking you to plot those 3 points. So 2, 0, that's 2 in the x direction, 0 in the y direction. So we're looking at that point right there. 2, 5. 2 in the x direction, 5 in the y direction. So that point right there. Okay. Now it says 0, 2. Okay. So 0 in the x direction, 2 in the y direction. All right. Those 3 points, if they're collinear, there should be one line that I can draw that touches all 3 of those. And when I say draw a line, it means that that line cannot bend, it cannot curve, it cannot have gaps or holes in it. It has to be straight. In this situation, there is no line that can touch all 3 of those points. Okay. So this would be non-collinear. Okay, some of you might have a situation where they were collinear. So maybe that would be a situation with those 3 points. That would be collinear because there's one specific line that will go through and touch all 3 of those points. Okay. Another example of maybe collinear would be maybe those 2 points along with that third point. There's one specific line that can be constructed, that can be drawn through those 3 points. And that's what the difference between collinear and non-collinear means. This one's question 38. Says use the number line below where RS is 6y plus 2. Okay, that's that distance from that point to that point. It says ST is 3y plus 6. And then RT, the entire distance, is 11y minus 2. So as we do questions like this, is the segment addition. Segment addition says you should be able to take that segment there, add to it that segment there, and it should then total the entire red segment from S to T, or sorry, R to T. So we're going to take the yellow part, which is 6y plus 2. We'll take the green part, which we said was 3y plus 6, and that should then end up equaling the entire red part, the entire segment, 11y minus 2. Combine like terms, I'll get 9y on the left plus 8 is equal to 11y minus 2. Add 2 to both sides, I'll get 10 over here. At the same time, we'll subtract 9y from both sides, I should get 2y over here. Y then is equal to 5. If y is equal to 5, now they're going to ask us all these other values, so might as well just come up here. If y was 5, 6 times 5 is 30, plus 2 is 32. So the yellow is 32. Here, if y was 5, 3 times 5 is 15, plus 6 is 21. And then the whole red part was 11y minus 2. 5 times 11 is 55, minus 2 is 53. And that then, looking at those two and adding those together, 32 plus 21 does give me that 53. So I should be pretty confident in my answers when I plug those in here, because that kind of built-in check there by finding all three parts. Question 39 is kind of a pain in the butt. They put this picture over there. But what they're telling you in this picture, and with the vocabulary word, we don't necessarily need the picture because of this vocabulary word and the statement here that T is the midpoint of PQ. So if I look over here, that tells us that PT is the same thing as TQ. All right, that midpoint tells us that the two distances for those segments have to be equal. So PT, they're telling us, is 3x plus 6, and TQ is 5x minus 6. Okay, I'll subtract 3x from both sides, I get 2x here. I'll add 6 to both sides, get 12 over here. Divide both sides by 2, x is 6. Now pay attention, they don't want what x is, they want what PT is. So plug it back into PT. 3 times 6 is 18, plus 6 is 24. Now I would just double check myself, because if that's true, then TQ has to be 24 as well, because TQ should be a congruent segment. So 5 times 6 is 30, minus 6, 24 again. And that solidifies the idea, or verifies that that point there had to be a midpoint, because I got 24 here, and I got 24 over here. Question 42 is similar to things we've already seen. It's kind of we go back to the angle bisector question or the angle addition questions. This kind of follows in the same type of problem. However, it's a little bit different. They say straight angle here. Okay, there's the relationship that we need. If we have RQT as a straight angle, that means from R to Q to T, it incorporates 180 degrees from R to Q to T. So we have 180 degrees as a total for that angle there, for that red angle, and that blue angle. So if I add the red to the blue, I should get 180. Okay, so I'm going to take 12x plus 2 and add to it 7x plus 7, and that should total 180. Okay, so I get 19x plus 9 is equal to 180. Subtracting 9, give you 19x is equal to 171. Divide both sides by 19. I believe that gives you 9. X is 9. So now if I know x is 9, I'll come back up here. We'll plug in 9 there. So we get 7 times 9 plus 7. Go ahead and evaluate that. Do the same thing here. 12 times 9 plus 2. Evaluate that. Okay. Those two totals then, when you evaluate them, should add up to 180. And that's your kind of built-in check, like I said earlier. That will tell you that, yes, I feel comfortable that's the correct answer for RQS, and that's the correct answer for TQS. All right. This question is another angle bisector question. It's very similar to the one that we saw earlier. Basically, what we're telling you here is that that angle there and that angle there are congruent because that angle, or that ray GH, is an angle bisector. So if they're congruent, their parts 3x minus 7 is exactly the same as 4x minus 16. Since we've already seen an example like this on the test, I'll go ahead and let you solve that and then evaluate for these missing angles. So let's find the midpoint of the line segment joining these 2 points. If you remember, the midpoint is an ordered pair, and that subscript just reminds us that that x and y are for the midpoint. And and it's equal to x sub 1 plus x sub 2 over 2, and y sub 1 plus y sub 2 over 2. And that's the formula for our midpoint. Now, you let these be your x's, x1 and y1, and this point here can be x2, y2, or vice versa. It doesn't matter which is which. But you're just basically going to add your x's. So we'll have negative 5 plus 1, and then we'll divide by 2. And then we'll add our y's with 2 plus 3, and we'll divide by 2. It says type your answers in ordered pair, use integers or simplify fractions. So the way I read that is that I do not use decimals, integers, or fractions. So I'll have negative 4 divided by 2, and here I'll have 5 divided by 2. Well, negative 4 becomes negative 2, or negative 4 divided by 2 becomes negative 2, and 5 halves stays as 5 halves. It does not reduce. It asks you to type as an ordered pair. That symbol there and that symbol there are critical for typing something in as an ordered pair. If I just write it as negative 2 comma 5 halves, it's going to count it wrong because that's not ordered pair notation. So if you've missed it because of that, learn from that mistake and try not to make it any other time, because it's going to be throughout the rest of the year. When they say ordered pair, type in as an ordered pair, they want the parentheses. This question here is a little bit simpler than the last one. The last one was doing it in 2 dimensions, an x dimension and a y dimension, left and right and up and down. This is just a singular number line. Okay, so it's just going from left to right. Maybe negative 2 is here and positive 11 is over there. We want to find the midpoint between them. Okay, so it's just like looking at just the x-axis. When we looked at just the x-axis just a minute ago, it was we took our x-coordinate, added to our second x-coordinate, and then divided that by 2. Okay, well, this here is representative of our first x-coordinate, and this is our second one. If I add those together, I get negative 2 plus 11 all over 2. And that gives me, 9 halves? Okay. So 9 over 2 is what we're looking for that answer. Okay. Which is 4.5 as a decimal. I'm assuming because there's not really specific directions here, they would have accepted either one of those 9 halves or 4.5. Maybe if you're reading notes or PowerPoint, sometimes we call that A and that B, and then the formula was instead of x1 plus x2, we said it was A plus B divided by 2. Doesn't really matter. They're still the endpoints of our segment, and we're gonna add those together and divide by 2. Basically, find the average of those 2 endpoints. The distance formula, if you remember, the distance formula is distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And it doesn't matter the order that you subtract your x's or subtract your y's. Because of the squaring procedure, it's going to make anything positive anyways. So my 2 ordered pairs are 7 and negative 2, and then negative 28 and negative 122. Okay, so I'll subtract my x's. I'll take 7 minus negative 28. 7 minus negative 28, it gives me 35. I'll eventually square that. I'm then going to add to it, subtract my y's. Negative 2 minus negative 122. So negative 2 minus negative 122 becomes negative 2 plus 122. So it gives me 120. And I'll square that. So the two values, when we take 35 squared, you'll get 1225. Take 120 squared, and you get 14,400. I'm going to add those together. Okay, and it gets 15,000. Just a second, hold on. 1225 plus 14,400. Yeah, 15,625. Just double checking myself there. 15,625. That is actually a perfect square. And the square root of 15,625 is 125. So that's what we're looking for. The distance between those two things is 125. Now the last question. Reminder that this is they give us the midpoint. We want to find the other endpoint. So this is the formula we use. And remember that when we have this and we're trying to find the other endpoint, we're going to remind ourselves that that there equates to that. So we'll have x sub m is equal to x1 plus x2 over 2. This here equates to that. So we'll end up with y sub m is equal to y sub 1 plus y sub 2 over 2. Now, that there, 16 comma 14, those are the coordinates of the midpoint. So the x coordinate for the midpoint is 16. This is one of my endpoints, so that's an x sub 1. So I have 8 plus an x sub 2 over 2. This 14 is the y coordinate of my midpoint, so I put 14 here. Y sub 1 is my 19, plus then y sub 2, which we're looking for, and then divide by 2. I'm going to multiply this. I'm going to do this one first. I'll multiply both sides by 2 to get 32 is equal to 8 plus x sub 2. I'll subtract 32 from both sides. Sorry, subtract 8 from both sides. And that's going to give me 24 is equal to x. Okay. Over here, I'll double both sides again, get 28 is equal to 19 plus y sub 2. I'll subtract 19 from both sides, and that should give me y sub 2 to be 9. Now the only thing is, make sure you pay attention to the directions. Type as an ordered pair. So when I type that as an ordered pair, what I'm looking for is a parenthesis, the x coordinate, which is 24, comma, the y coordinate, which is 9, and then I finish it with a parenthesis.